They tow buses down the highway and haul heavy military equipment through the forest. They move the world's largest aircraft, recover tanks from war zones, and haul enormous launch vehicles. These heavy-duty transporters are among the most powerful towing and recovery vehicles in the world.
This aircraft can weigh up to 400 tons. I can move it with a tow truck that's just 40 or 45 tons.
These towing vehicles often transport 30 times their own weight, and the loads they carry are huge.
That's 1,300, 1,400 tons on the hook and back.
These specialty vehicles are called into action when exceptionally heavy loads need to be transported or recovered. Their missions are often dangerous ones, so safety is a top priority.
It could easily kill someone if it snapped.
They get called in for the toughest jobs and the heaviest loads. The mega towers, the most powerful recovery vehicles in the world. Decked out in camouflage paint, the Bison military recovery vehicle was designed for use in war zones. The 503 horsepower behemoth can tow up to 50 tons. And its armor helps it survive shelling and blasts from landmines filled with up to 10 kilos of TNT. The German armed forces currently own 12 of these vehicles. Today, a 2-member crew is on a training mission. A 10-ton military vehicle is stranded at the roadside. It's the Bison crew's job to recover it. Master Sergeants Robert Nickel and Frank Ulbricht start with a survey of the deployment site.
Attach it here?
Right.
Yeah.
They calculate the tensile forces that will come into play to ensure nothing's damaged during the operation.
The factors we have to take into account are the terrain, the weight of the vehicle, and what the ground's like. With a high center of gravity, I calculate using the entire vehicle weight. With a low center of gravity, like here, I'll use half the weight of the vehicle. So if we assume roughly 10 tons here, we'll calculate a maximum of 5 tons of tensile force. All right, radio's on. Tell me where to go.
The 35-ton Bison is moved into position, allowing the deployment of both the front and rear winch. The soldiers position 2 heavy return pulleys on either side of the truck. 2 sturdy trees will serve as supports during the recovery maneuver. Master Sergeant Nickel has to use all his strength to pull the 50-meter cable out of the self-recovery winch. It has a rating of 10 tons. Then he spans it into the first return pulley, which is already attached to a tree. The main recovery winch is located at the rear of the Bison. Master Sergeant Ulbricht drags the 120-meter-long cable to the second return pulley. It's looped around the tree, clipped and bolted. The second attachment point is now ready to go. They move on to the capsized truck. They need a sturdy spot to attach the shackles.
If we picked a different spot, like say the tail lift, it would just be ripped off. So that wouldn't work.
The recovery vehicle is attached at 2 points. Now the truck will be carefully hoisted back upright. One winch is used to pull, the other to stabilize the vehicle. That helps prevent damage. In a wartime situation, the military truck would need to return to duty as quickly as possible. The Bison is also secured. The recovery jacks at the rear help stabilize it on the soft ground.
If we don't do that, the vehicle could end up subsiding and slide in the pull direction, or even hit the tipping point. The 2 ropes could tip the vehicle over. That would be fun.
This setup will keep the Bison from tipping. The winches attached to the trees help with that too.
Up to 5 tons of weight force are acting on this cable, all the way up to the return pulley, pulling it in this direction. On the other side, there's 5 tons of tensile force pulling toward the vehicle. Both forces meet right in the middle of the return pulley. Those forces are additive, so we have to find a tree that's strong enough to withstand 10 tons.
The two recovery experts have to estimate what load the trees can bear based on experience. Master Sergeant Robert Nickel climbs into the armored cab. He'll guide both winches simultaneously by remote control.
Right. I'll move.
Thank you.
Okay, let's get going.
Experience, good instincts, and teamwork all come into play.
The self-recovery winch is in place.
The main winch at the rear of the Bison helps secure the 10-ton vehicle from a hard landing. On the other side, the Bison slowly pulls the truck back upright.
Engage the winches, slowly.
The soldiers maintain control over the truck at all times. As long as it doesn't tip over, it won't be damaged.
We have to make sure the winches are engaged so that one side tracks and the other side pulls properly.
Release main switch and stop.
The Bison saw its first deployment in 2012 in Afghanistan. It was the first vehicle of its kind that could recover loads of up to 40,000 kilos this quickly and efficiently. After 45 minutes, the capsized truck is upright again.
And done. 10 tons on the ground.
Phase 1 of the recovery operation is complete.
Our mission is successful so far. We got the vehicle upright without any complications. It didn't slide or fall, and we'll be able to tow it without significant damage.
Phase 2 is next, the towing. They'll only use iron chains. In a combat scenario, this would be the fastest way to get out of possible danger. The lift arm extends backwards, and the heavy recovery chains are looped around the front axle.
We looped our regular recovery chains around the axle, which created a secure connection.
Fully extended, the Bison's lift arm can hoist 10 tons. But Master Sergeant Nickel retracts the arm part way. They'll soon be driving at top speed, and the forces exerted on the lifting cradle will be immense. The truck is hoisted 2 meters into the air. Now it's hanging by its own weight on the chains. Only the 2 rear axles are still on the ground. The flag is attached, and they're ready to go. Master Sergeant Ulbricht draws on the engine's 500 horsepower and gets the Bison moving along the unpaved road. The recovery vehicle soon reaches the maximum speed of 85 kilometers an hour. The Bison used by the German armed forces consumes 60 liters of diesel per 100 kilometers. In the armored cab, the 2-member crew is protected from shelling and attack. All-wheel drive powers the 12 tires on the 4 axles across even the most difficult terrain. The 35-ton Bison costs 1.2 million euros, making for a truly high-end recovery vehicle. At the Leipzig-Halle Airport, flights are on a tight schedule. 65,000 aircraft pass through here every year. 175 takeoffs every day. Airplanes can't move backwards easily. That's why tow trucks haul them from gate to gate or give them what's called a pushback onto the runway. This AST-3 aircraft tractor might not look like much, but it's a real powerhouse. Clocking in at 9,000 kilos, the tractor can move aircraft weighing up to 160 tons. Pushback specialist Thomas Fulle has been operating vehicles like this for years. Using an AST-3, he can move an average of 10 aircraft per 8-hour shift. A few minutes before takeoff, the tractor approaches the airplane. The driver first needs to assume control over the aircraft. This simple steering pin makes it a snap.
This is the steering pin, which temporarily deactivates the aircraft's steering unit. The captain could still brake, of course, but he won't do that because it would create a big jolt. I'm fully in control of the steering, which is a nice feeling. In theory, I could do whatever I wanted with the aircraft.
Once the steering pin is in place, the pilot in the cockpit releases the parking brake. Thomas Fuhrle now assumes control of the 150-ton aircraft. The tractor then docks its lifting mechanism onto the nose wheel and gets ready to take the aircraft for a ride. The AST-3's hydraulics allow the aircraft to lift off before it gets underway, even if it's just by 30 centimeters.
I try to move forward so that the pushback and the aircraft end up in a straight line.
The aircraft is undocked from the boarding bridge, and the pushback maneuver begins. The tractor and cockpit remain in constant radio contact. The tandem will now make its way 300 meters across the wet tarmac. The AST-3 is equipped with hydrostatic power steering. That allows for gentle acceleration without changing gears, up to a maximum speed of 33 kilometers an hour. That might not sound like much, but when it comes to moving aircraft, power comes before speed. Conditions today are less than ideal, but the all-wheel drive has enough traction on the wet tarmac to move the aircraft safely into position.
At this time of year, it's still relatively easy. The big problems come in the winter. Right now, the only problem is that reflections make it hard to see.
But steering the tractor-aircraft tandem always poses a challenge. When the driver steers to the left, the aircraft swings right, and the same goes for the other way around. At higher speeds, the driver has to maintain a specific steering angle for safety reasons. The permitted angle of steering varies according to the model of aircraft. One of the special features of the compact AST-3 pushback tractor is its special lifting system.
Most of the force ends up here, which is what supports the wheels. This part helps me push the aircraft out. This back is fastened to make sure the aircraft is securely connected to my truck.
Special sensors on the lifting device allow the AST-3 to automatically detect what model of aircraft it's dealing with. For each aircraft model, the maximum tensile and brake force is set automatically. Airports around the world swear by this small but mighty towing vehicle. The 28-ton Colossus is on home territory, the A10 motorway near Berlin. The yellow bison belonging to the German Automobile Association ADAC is called in when buses, trucks, or transporters weighing 40 tons and up need a tow. The crew has just started their 8-hour shift. Whenever a heavyweight is stranded south of Berlin, a call comes in.
A tow home? What's wrong with it?
150 heavy load service calls arrive here every year. 80% of them require towing. The information is immediately passed on to the Bison. The two-man crew sets out to answer the service call. Although it clocks in at 28 tons, thanks to its 500 horsepower turbocharged V8 engine, the 10-meter-long Bison has a top speed of 88 kilometers an hour.
A truck like this isn't fast, at most 88 kph, but it has more gears than a car, so the engine's power can be transferred more efficiently. You need that power with a truck like this.
Its 14-speed range splitter gearbox features twice as many gears as an ordinary truck.
There's also a question of fuel consumption, 58 liters per 100 kilometers, which is quite a lot.
The Bison is headed to the scene, a few kilometers from the motorway. A 13-ton bus has broken down on a busy rural road. 15 minutes after the emergency call went in, the mega tow truck is on the scene. Even for the experienced Bison crew, hauling a bus is not an everyday event.
Hello? You can see the problem. I'm stuck here. Okay, let's get going.
There's a problem with the automatic closing mechanism on the doors. The bus won't move when the doors are open. This isn't the type of scenario the Bison crew normally encounter. They're usually called out for trucks that have broken down.
We see quite a few trucks, because the trucks used by Eastern European companies aren't always in perfect technical condition.
First, the crew secures the site. Otherwise, they'd be risking their lives. Oncoming traffic passes by them at a high speed just a few centimeters away.
It's pretty dangerous, especially the trucks. Their drivers don't always manage to switch lanes, so they're sometimes less than a meter away when they barrel by. When you're standing there, you really notice what kind of power and momentum they've got behind them.
They have no time to lose. The bus needs to be towed as quickly as possible. The first step is lowering the Bison's powerful hydraulic lift arm. This arm is what will do the heavy lifting.
We'll push this under the front axle of the bus. This is what the front axle will sit on.
They have to make sure it's a perfect fit. Crew member Benjamin Guest reverses the Bison toward the bus. If the wheels aren't sitting on the mounting properly, the bus could jump out when they're at full speed.
A bus like this has wide tires, so the mounting has to be extended.
The lifting arm's hydraulic system handles the final few centimeters. The lifting cradle's steel brackets are adjusted by hand. They'll have to withstand the largest forces during towing. A single mistake could end up causing serious damage to the bus when they reach full speed. Now it's time to lift the 13-ton bus. But something's not perfectly aligned.
Is there room in the back?
Not much. We'll have to let it down again.
If it bounces on the road, it will break.
Nah, it won't.
The bus is still too low. So the crew tries to squeeze out another centimeter.
Let's push the steel bracket a bit further together. So then we can squeeze the tires a bit and get more ground clearance.
Everything looks fine in front now. But what about the rear of the 20-meter-long vehicle?
The rear wheels have contact with the road. There will be some bumps in the road, which will jostle the bus a bit, but we don't want any damage.
The wheels are fastened with straps so that the bus remains firmly in the mount. It's dangerous work here in the middle of the road. For towing crews, danger is part of the job.
You can see the truck traffic here. There's not a lot of room. If a driver doesn't pay attention or is distracted, you hate to think what could happen.
So far, everything's going according to plan. But before the bus can move, it needs some air in the brake system.
In a car, the brakes operate hydraulically. In a truck or bus, it's a bit different. It's pneumatic. You activate your brake pedal, and then pressurized air activates the brake calipers. If that pressurized air is missing for some reason, at a certain pressure, around 5 bar or so, it would brake automatically, and we don't want that to happen.
Without the Bison's pressurized air supply, the brakes would start to smoke and cause expensive damage. After about an hour, the bus is ready to be towed. In another location, preparations would take a lot longer. The drive shaft would have had to be disconnected from the transmission.
The wheels keep turning because they're rolling. That would have transmitted force to the transmission. The damage to the transmission would have run into thousands of euros.
For a distance of 10 kilometers or less, that's not a problem, say the pros. So they can pack up and leave. After more than an hour, the bus is on the move. The bus company will pay about €750 for the towing. With a 13-ton bus in tow, it's clear that the ADAC Bison is a real powerhouse among recovery vehicles. When heavy military equipment is stranded, this is what comes to the rescue: a Büffel. The armored recovery vehicle of the German Armed Forces can tow 62 tons with ease. It reaches speeds of up to 65 kilometers an hour and can handle most any ground conditions. The 54-ton powerhouse can do it all: rescue vehicles stranded in water, move capsized tanks, and clear massive obstacles out of the way. Not everyone can drive a tank like this, let alone handle the towing operations. Soldiers receive special training at the German Armed Forces Logistics School near Bremen. The soldiers learn how to control the Büffel in every imaginable scenario. When they're done, they'll have mastered the most complex recovery and towing technology. Master Sergeant Udo Müller is an armored vehicle specialist and heads the 5-week training program on the Büffel. The first lesson: leaving the hangar. The armored vehicle is 9 meters long, 3.5 meters wide, and 2 meters 70 high. The inexperienced driver needs the guide's signals to maneuver the huge tank. After 5 weeks training, they'll be experts, part of a small elite group of soldiers in the German military.
We're always there when things get tough. When something's happened, when a tank is down, we support the combat troops. We're quite a small, elite team. Specialists, in other words.
Time for the second lesson: recovery under fire. Using the Büffel's high-tech battlefield tow bar, a downed armored vehicle can be removed while the battle is still raging. And the crew don't have to leave the recovery vehicle.
He needs to make sure he drives to exactly the right spot so that the clevis ends up right on the pin.
The soldier in the front of the hull uses a camera to help navigate. The clevis has to be placed on the pin with care. Bullseye. After 5 minutes, the 62-ton Leopard 2 battle tank has been rescued, along with the soldiers in it. Despite enemy fire, mission accomplished. But that's not all the Büffel is good for. Its rotatable crane can lift up to 30 tons. That allows it to replace extremely heavy parts, like an engine or transmission on a standard battle tank. With its own 6-meter boom, the Büffel can even replace its own engine.
When the boom is extended like this, that display tells us the load. In this position, we can lift 12 tons.
When the Büffel is right next to the tank, it can lift its maximum load of 30 tons. The soldiers train for all sorts of critical situations. Here, they're swapping out a gun turret in the middle of a maneuver. The Büffel can do it all, recovering heavy loads, lifting, pulling, and pushing.
This here's the dozer blade, which can carry out all sorts of excavation work, clear obstacles, and build emplacements for a battle tank which has to be recovered from a secure position. This is our main recovery winch. It's the cable we use to recover vehicles or battle tanks.
The steel cable is 160 meters long. That allows the Büffel to rescue a standard battle tank from a great distance, even under enemy fire. The hydraulic winch generates a constant tensile force of 35 tons.
If the cable broke, it could easily kill someone. It's at such a high tension that it would whip around in an uncontrolled way. You really don't want that to happen.
The Büffel is a real powerhouse. The brawny recovery vehicle has no trouble pulling heavy tanks out of the mud. Using a return pulley increases the tensile force to 70 tons. With 3 cables, the Büffel can tow up to 105 tons. But it's a real gas guzzler. Its tank can hold up to 1,600 liters of diesel. At a gas station, it would cost about 2,000 euros to fill to the brim. And its range is just 300 kilometers on a full tank of fuel.
By comparison, cars have a range of 5 to 6 liters per 100 kilometers.
Compared to a passenger car, though, the Büffel sports 1,500 horsepower and 47.2 liters of engine displacement. In conjunction with the 12-cylinder engine, the hydraulic transmission, steering, and reverse gears, it generates so much power that it can tow up to 72 tons at full speed. The third lesson is about to begin: towing using a so-called scissor bridge. The Büffel carefully backs up to the stranded tank. The young soldiers take out the 2 rods that make up the scissor bridge. The 2 soldiers make a mistake while bolting the strut to the tank. Master Sergeant Udo Müller corrects it right away.
The specifications are that the bolt always has to be inserted from the outside to the inside. That's not the case there. We're taking the headlight off so that we can put the bolt in correctly.
The headlight comes off and the bolt is removed. Master Sergeant Müller keeps a sharp eye on every detail. In a combat scenario, even a small mistake could spell disaster. Now it's time to head out. The Büffel needs to be positioned perfectly.
Connection done, hazard zone clear, engine on.
The 1,500 horsepower diesel engine fires up. It's incredibly loud. From this point on, the driver and the guides can only communicate by radio. The 2 young soldiers are struggling to bring the huge Büffel into the perfect position, while pulling the scissor bridge to the proper height. Something's wrong with the radio transmission.
I've got to hold the button down, so to speak, so I've only got one free hand.
Experience counts. A push of a button on the headset, and the problem's solved.
What command gets you a turn around the yaw axis going right at the rear? No, a turn on the yaw axis means a forward command. Front goes left, back goes right.
Time for the second attempt.
Hazard zone clear. Engine on.
This time is more successful. The scissor bridge slowly approaches the correct position, and the bolt engages.
Braking doesn't work the way it does in a car. Here, it's a bit more robust. So you have to be gentle with the brake.
The 2-rod scissor bridge will allow the convoy to travel at top speed while maintaining control.
One rod wouldn't provide enough stability. The tank in the rear would lurch sideways and veer back and forth in an uncontrolled way. The Büffel wouldn't be able to transfer the force properly to make it safely around a curve. That's why we need the towing fork. It helps us tow the tank safely. We can also use it to maneuver. We don't only tow pulling forwards, sometimes we have to push backwards or sideways.
The 120-ton convoy leaves the yard. The soldiers need to practice how to drive the Büffel. They could be called on to drive at speeds of up to 68 kilometers an hour on difficult terrain. In the worst-case scenario, they could find themselves under enemy fire. With its 12-cylinder diesel and 1,500 horsepower, the recovery tank plows its way forward. The Büffel is an off-road recovery tank of the highest order. It's busy at the Leipzig-Halle airport. The Antonov 124 is one of the largest cargo planes in the world. It's scheduled to take off here today. 5 Antonov 124s are stationed in Leipzig. These aircraft can deliver unusually large and heavy payloads all over the world. An F-396 tow tractor is on the way. This flat all-wheel drive tow tractor is the only vehicle of its kind that can pull a fully loaded Antonov across the runway. With a length of around 70 meters and an empty weight of 173 tons, the aircraft can transport up to 400 tons of freight through the air. The nose and the tailgate in the rear can be opened. The ramp can be extended so far that dozens of vehicles or ultra-heavy machinery can be driven into the hull.
They transport trucks, turbines, machinery used in oil refineries, large-scale relief supplies. Any big and heavy technology can be transported. With this aircraft, I could fly 2 of my heavy tow tractors anywhere in the world. Each one weighs 45 tons, and this aircraft could easily move 2 45-ton tow tractors to Frankfurt if our colleagues there needed the additional support.
Shortly before takeoff, Thomas Furler gets a second call. His tow tractor is needed to help shift a stranded Antonov 124. The F-396 is just 9 meters long and 3 meters wide, but it's able to haul aircraft that weigh up to 420 tons. How can this rather unassuming-looking vehicle shift such an immense weight? Its secret is that it weighs 45 tons, sports 2,000 Newton-meters of torque, and has a special gearbox. The F-396 is manufactured in Ostfildern, just outside Stuttgart. The Schopf company specializes in tow tractors for aircraft, all sporting the label Made in Germany. They produce up to 230 vehicles of various kinds each year. A powerhouse like this sells for 400,000 euros and up. One of the most important work steps is what's called ballasting. That entails moving a heavy steel block into the chassis. Depending on the intended application, the F-396 weighs between 46 and 70 tons. That weight is important.
We add as much ballast as the client needs. The vehicle has a certain amount of power, and depending on its weight, it can put that power into action. If it's not heavy enough, its wheels will just spin. With ballast, the vehicle can weigh up to 70 tons. That's the upper limit.
The tow tractor's weight pushes it into the ground. That way, the 4 tires have enough grip on the road so they won't start to slip and spin. But the true secret ingredient is in the engine compartment. To tow something as heavy as an Antonov, The F-396 comes equipped with a 1.5-ton powertrain, the diesel engine plus the gearbox. The six-cylinder diesel engine has 12 liters of engine displacement. With a maximum of 2,300 revolutions per minute, its power is transferred straight to the power shift transmission.
The power goes straight into the transmission. The many gears here transmit the power to the output here, and the output on the other side.
And they drive the front and rear axles at the same time. The powertrain then generates 450 horsepower, about the same as a sports car, but a sports car would never be able to tow a 400-ton aircraft. 2,000 Newton meters of torque give the F-396 its enormous tensile force. Like a diesel locomotive, the slow and powerful tow tractor will set the aircraft on the tarmac into motion. A drawhook test will now determine whether this vehicle is powerful enough to tow an Antonov. The specifications that the tow truck needs to meet can be precisely calculated.
There's the vehicle's mass and the mass of the aircraft that's to be towed, plus about 6% of roll resistance and a slight incline at the airport also go into the calculation. That's how we arrive at the towing vehicle's required performance rating.
The test run gets underway. The driver starts the engine and steps on the gas. The tow tractor pulls with all its might on the hook. The test is over when the wheels start to spin. The driver pushes the vehicle to the limit. At 380 kilonewtons of tensile force, they call it quits. The wheels have started to spin. This tow tractor didn't hit the 400 kilonewtons needed for a fully loaded Antonov.
The vehicle could pull a lot more if we added more ballast to the 70 tons. But it's not as heavy, so the wheels start to spin more quickly, and it can't manage 420 kilonewtons. The wheels start to spin at just under 400 kilonewtons.
So along with the engine and transmission performance, when it comes to tow tractors, the vehicle's own weight makes a difference. At the Leipzig-Halle Airport, Thomas Furle and the F-396 are headed toward a fully loaded Antonov 124. Furle will soon do a pushback, moving the aircraft to the runway 300 meters away. The cargo plane can't move backwards on its own. A special 3-ton bar connects the tow truck and the aircraft.
You need a special bar because the Antonov has a dual nose gear, which is something that you'll only see on a few aircraft in the world. To make sure that it all works properly, our Russian friends have developed a special bar, which is also very, very heavy. You can't attach this with just one person. You need a crew of at least 4 or 5 to attach this bar.
These 2 shear bolts are extremely sturdy. They ensure that the 400-ton aircraft remains securely attached to the tow tractor.
You don't want the shear bolt to break, but with these smaller vehicles, it is a risk. The bolts are designed to ensure that they absorb the damage, rather than the aircraft. The bolts cost just 80 euros. When you consider the thousands or hundreds of thousands it might cost if we damage the aircraft, 80 euros is quite cheap.
The colleagues are already there, getting the special tow bar ready for business. Now the tow tractor drives up to the special adapter. It has to be a perfect fit. After 5 minutes, the connection is in place, and the control tower gives the all clear.
Thank you.
The F-396 slowly moves the Antonov out of its parking spot. For a few minutes, the special tow tractor has full control over the aircraft and its valuable cargo.
We don't always know what's inside, but I could imagine that each of these crates holds cargo worth 50 million.
Moving this giant aircraft takes full concentration. The towing bar between the Antonov and the tractor operates like a joint. When Thomas Furler steers to the left, it pushes the Antonov to the right, and vice versa. After 3 minutes, the aircraft is at the starting position. The 3-ton bar is now disconnected. Thomas Furler and his F-396 tow tractor begin their retreat. Their work is done.
We've been doing this for 10 years now. It's still exciting because it's a bit different every time. We always try to make sure that the aircraft stays on schedule. That's our goal.
The Antonov takes off from the Leipzig-Halle airport on schedule. The airline company doesn't reveal where the freight plane is headed and what kind of cargo it's carrying. The F-396 tow tractor has made a good job of it. It can tow or push 10 times its own weight with ease. This enormous power makes it truly stand out. In South America, an Ariane 5 is about to head out into orbit. A countdown like this takes place every 8 weeks near Kourou in French Guiana. The nearly 60-meter-long Ariane is the world's most reliable launch vehicle. Getting the Ariane 5 to the launch platform takes a special truck. The blue ESA tow trucks are made for this purpose, and they're truly the kings among towing vehicles. The oldest vehicle in this fleet is a made-to-order towing vehicle made by the MAN company in 1991. The truck is powerful enough to move the 1,500-ton launch assembly into position. The mega truck plays an important role in delivering payloads into space. An Ariane 5 takes off from here every 2 months, transporting satellites into orbit or bringing supply modules to the International Space Station. On the ground, the 56-meter-tall launch vehicle has to be moved several times to various locations at the spaceport. It's a tough job, even for a truck as powerful as this.
This rather unassuming-looking truck is a real standout. It has special gears. It will be moving the launching base, which weighs 750 tons, along with the launch vehicle, which hasn't been fueled yet. So it will be towing more than 1,300 or 1,400 tons, but this truck is equipped for that.
In the early 1990s, MAN came out with the most powerful truck in series production. It sports a 500-horsepower V10 engine. The all-wheel truck can tow up to 1,850 tons at a maximum speed of 5 kilometers per hour. The Ariane 5 still has to be assembled before the mega truck can get to work. Several ships transport the giant components from Europe to Kourou. Here, in this enormous assembly hall on the spaceport grounds, the main stage is moved into an upright position. Then it's connected to the launching base. A few weeks from now, the Ariane 5 will be launched from this base, transporting 4 navigation satellites into space.
We're standing in front of the launch vehicle, which already has a lot of flammable fuel on board. Access is very limited, and we have to be very careful. It's very hazardous, so the entire team has to observe all the safety regulations to make sure nothing terrible happens.
The entire launch setup has already been placed on tracks. 48 steel wheels distribute the weight of the 750-ton launching base and the 750-ton launch vehicle evenly across the two tracks.
To reduce friction between the wheels and the tracks, a lubricant was applied here during transit. We haven't always done this, but over time, we realized that it's better for the track system. Then we don't need to do as much maintenance work on the tracks. The truck is connected to this coupler. It's hard to imagine, but the entire weight of the launching base and launch vehicle will be attached to this. These pins will pull 1,400 tons. And you just have to trust in the fact that this is what the truck was born to do.
The Ariane 5 has to move to a new location. The satellites are waiting in an assembly hall about 1,000 meters away for what's called the marriage. The megatruck is called in. Only the driver and a few select crew members are permitted in the vicinity. The solid rocket boosters on the side, which generate about 45 million horsepower of thrust on takeoff, are highly explosive. All of the spaceport workers within a 1-kilometer radius have left the area. For the ground crew, this is a routine operation. The convoy moves along the 1-kilometer stretch of tracks at a speed of 3 kilometers an hour. In the second building, 4 satellites are mounted onto the launch vehicle. Then it all gets a thorough inspection. 2 weeks later, the Ariane 5 is ready to move on. The launch pad is 3 kilometers away. The megatruck tows the enormous launch base and vehicle to the launch pad. The entire area is once again evacuated. Even the smallest mistake could spell disaster. After more than 2 hours, the convoy has reached its goal. Another Ariane 5 launch vehicle is ready to defy gravity and transport 4 navigation satellites into space. On the ground, the Ariane 5 can't move faster than 3 kilometers per hour. But during takeoff, the 2 solid rocket boosters accelerate the 750-ton launch vehicle to a speed of 11 kilometers a second, 10 times faster than a speeding bullet. Compared to this display of power, the blue tow truck seems almost tame. But its tensile force of 1,850 tons makes it the undisputed king of towing vehicles. From buses to armored tanks to aircraft and launch vehicles. Whenever ultra-heavy loads need to be moved, it's a job for the world's most powerful towing and recovery vehicles. Without them, heavyweight loads would remain rooted to the spot.